Hi everyone, this is part 2 of your chapter 5 to 7 test review. In the next few problems, we're going to review hypothesis testing. So this was everything that we did in chapter 7 over the last couple weeks. So you're going to see 3 hypothesis tests on this study guide, and I'm also posting the answers to this in Polaris if you just want to look through those and maybe try the problems on your own, or you can watch along with the video if you'd like. And then there's also a practice test in Polaris at the very end. I believe there are 6 hypothesis testing questions, and then also the solutions to that are posted if you want to practice on your own a little bit during class today or this evening. All right, so number 10, it says a consumer group claims the mean acceleration time from 0 to 60 miles per hour in a particular sedan is at most 6.3 seconds. A random sample of 33 sedans has a mean acceleration time of 7.2 seconds. Assume the population standard deviation is 2.5 seconds. At a level of significance of 0.05, test the claim, interpret the results, make sure to show all of your work. All right, so I'm going to start by pulling out the important information from here. We're going to start with the claim. The claim is that the sedan has an acceleration time at most of 6.3 seconds. So that mean that we're going to be testing for the population value is going to be 6.3 seconds, and we're going to use the word at most in a few minutes. We'll see that inequality sign pop up when we write our null and our alternative hypotheses. A random sample of 33 sedans, so that is my n, has a mean acceleration time of 7.2. That's our x bar. We are also told here that we have the population standard deviation. Remember, that's our key word. So we know what test we're going to use. Because I have that, we know we can use our z-chart instead of our t-chart. Our level of significance we were given is 0.05, and we're ready to go ahead and write our claim, our null, and our alternative. So let's start with the claim. Make sure when you write these you label which is the claim. It's at most 6.3 seconds, which means we're going to use less than or equal to 6.3 seconds. Because it is equal to, as the statement of equality, that means my claim is the null hypothesis, and therefore the alternative is the complement of that, greater than 6.3 seconds. The alternative also tells you what kind of test you have. Because it's greater than, we know we're going to have a right tail test. Okay, so let's see what else we've got here. Our level of significance is 0.05. So if you guys take a look at your standard normal distribution at the alpha values that we wrote in, and these will be written in on the chart that you guys get on the test day, you're going to look for the alpha of 0.05, and you're going to look for a right tail test, and you're going to get that critical value of z. And again, we're doing this on the z chart because we know the population standard deviation. So alpha 0.05, right tail test, you guys should be able to find on your chart. That is 1.645. So we can draw that, and that's going to create our rejection region. So 1.645 right tail is going to look something like that. Okay, so now we're going to find our z value based on the sample set of data. And the formula that we're going to use for this is as follows. You can find this under the Chapter 7 formulas on your sheet. And we have all this information. Our x bar is 7.2. Our population that we're testing, our population mean, is 6.3. Standard deviation is 2.5. And then the square root of our sample size, 33. And we're going to round that to 2 decimal places. So go ahead and type that in your calculator. 7.2 minus 6.3 divided by 2.5 over the square root of 33. If you're doing this in the red calculator, remember you probably want to do numerator and denominator separately and then divide last, so you don't have to worry about calculator issues or rounding issues. So I get 2.068. So if I rounded that to 2 decimal places, it's 2.07. So now we're going to compare our z value to our normal distribution over here, and 2.07 would be in the rejection region. Because it's in the rejection region, we will reject the null hypothesis, and now you want to interpret your results. And so remember the chart that we had on the board a few days ago about what the claim was and whether we reject or don't reject. In this case, my claim is the null, which means that we are going to say there either is or is not enough evidence to reject. That's what we're trying to do, reject the null hypothesis. In this case, because we did reject, we're going to say there is enough evidence to reject the claim by the consumer group. Okay, so make sure when you're doing this on the test, you're showing all of these steps. Your claim, your null, your alternative, you're drawing your normal distribution and that critical region, your rejection region. You're calculating your z, you're saying whether you reject or do not reject, and then summarizing those results and interpreting those results. All right, let's look at the next one. Number 11 says a travel agent claims that the mean price of a round-trip flight from New York City to Los Angeles is less than $507. In a random sample of 55 round-trip flights from New York City to LA, the mean price is $502 with a standard deviation of $111. At a level of significance of 0.01, test the claim and interpret the results. Make sure you show all of your work. All right, so let's again start by pulling out our important information, and actually we can maybe just start by writing our claim here and our null and an alternative. So the claim is that the mean price of a trip from NYC to LA is less than $507. So my mean less than 507. Because it's not equal to, that means my claim is the alternative hypothesis, which means the null is the complement of that greater than or equal to 507. Also, my alternative hypothesis is going to tell me what kind of tail test I'm going to have. This will be a left tail test because it is less than. Other information that we know, the random sample size was 55. And remember, I didn't mention this in the last problem, but we always kind of want to check as we're doing this that our sample size is either bigger than 30 or normally distributed. Both of these, we have sample sizes larger than 30. Let's see, we've got a mean price of our sample, so our X bar is 502. We also have a standard deviation, but it's a standard deviation of the sample, so we're going to use S here. And that's $111 because I do not have the population standard deviation. I only have the sample standard deviation. We're going to be using a t test when we do this. So that's how we know to look at the t distribution and get that critical value versus our z distribution. All right, our level of significance is 0.01. So we can go ahead to our t distribution and we can check for that critical value of t that we're going to need to look for. So one thing that you need to find your critical value of t, if you have n, one less than that is your degrees of freedom. So degrees of freedom is 54, and my tail is a left tail test, so that's a one tail test that you're going to be looking at on your chart. And the level of significance is 0.01. So what you guys need to do at your t distribution, if you want to look on your chart and kind of follow along with me, you're going to look at the line at the top that says one tail. You're going to go over to where it says 0.01. That's our level of significance. So you should see that that's the fourth column over on your chart. And then we're going to go down to 54. Now 54 is not on your chart. If you do not have a degree of freedom listed, you're going to choose the value that's closest to that degree of freedom but less than that. So we're actually going to use 50 degrees of freedom because that's the closest but less than the value that we have. So 50 degrees of freedom at one tail, level of significance 0.01, you guys should see 2.403 is our critical value. Now, whether it's left tail, right tail, or two tail, from your t-distribution, you need to adjust the sign. If it's a right tail, you use the positive. If it's a left tail like this one, you use the negative. And if it's a two tail, you use a plus and a minus. But again, because it's left tail, we're going to use the negative. And then you can go ahead and sketch that rejection region. So negative 2.403 is going to be over there somewhere. All right, so let's go ahead and calculate our t-value that we're going to see if it lies in the rejection region or not. This is going to be really the same formula that we used a moment ago. The only difference is in the denominator it's an S instead of a mu because we have the sample standard deviation. All right, so let's set it up. We've got 502 minus 507 is the mean that we're testing there. 111 over the square root of 55. And again, we're going to use our calculator. Going to round to a couple decimal places here. So 502 minus 507 in the numerator gives you -5. Then we're going to divide that by 111 over the square root of 55. And I get -0.334. So if we want to compare that to my rejection region, that would not be in the shaded region. It would be to the right of my shaded region. So we decide to not reject. We do not reject, or you could say fail to reject. And then we want to summarize that. Now remember here, the claim was the alternative hypothesis. So that's going to change our wording a little bit compared to how we did the last problem. Because we do not reject, we say there is not enough evidence and when the claim is the alternative, we use the word support. To support the travel agent's claim. Okay. All right, and we've got one more problem. Our hypothesis test, we did a Z, we did a T, and now let's do a P, a proportion hypothesis test. This one says, an education researcher claims that the mean high school graduation rate is 80%. You want to test this claim. You find that the random sample of 30 states has a mean high school graduation rate of 82%. Assume the population standard deviation is 5.1%. At a level of significance of 0.05, test the claim and interpret the results. Show all of your work. Okay, so anytime we're dealing with percentages, we're dealing with proportions. So now instead of means, even though it's a mean that we're looking at for that percentage, we're going to be using a P instead. So P is the population parameter and P hat is the sample parameter. All right, so some different things that we need to pull out from this. We'll start with our claim and our alternative and our null, like the last one. The claim is that the graduation rate is 80%. So the claim is that the proportion is equal to 80%, 0.80. And because that's a statement of equality, my claim is the null hypothesis, which means the alternative hypothesis is that my population proportion is not 80%. Other important information, my N, my sample size, is 30. The mean percentage from the sample, so our sample proportion, our P hat, is 0.82. Population standard deviation is actually extra information in these problems. You do not need it for this hypothesis test, so we're just going to drop that guy. My level of significance is 0.05. If we have P hat, we can also find Q hat. Q hat is 1 minus P hat. which is 0.18. If we have P, we can also find Q, 1 minus P, which is 0.20. All right, and let's see. So next thing we need is our critical values. When we do a proportion, our critical values are going to come from our Z chart. So we're going to be looking for a Z sub 0. All right, and if you want to grab your chart, follow along with me here. We need to decide what kind of test we have, left tail, right tail, or two-tail. Because my alternative is not equal to, we have a two-tailed test. So you're going to look on your chart. These are, again, the written in values that you have, and those will be written in for you on the test tomorrow. You're going to look for two-tailed test. You're going to look for a level of significance of 0.05, and you guys should see a critical value or critical values of plus and minus 1.96, which we can go ahead and sketch those rejection regions then. On both tails, negative 1.96 and positive 1.96. Okay, the next thing we're going to calculate is our sample statistic, and I'm going to go ahead and put that formula on here for you. Again, it is a Z value that we're calculating, and you can find it on your formula sheet if you need it. So we're going to use P hat minus P over the square root of PQ all over N. And we have all the information we need here. Actually, Q hat in this problem is also extra information. We use it for other things like confidence intervals, but we don't need it for our hypothesis testing. All right, so 0.82 is my P hat. 0.80 is the population proportion that we're testing. In my denominator, my P is 0.8, my Q is 0.2, and my N here is 30. All right, we're going to go ahead and calculate that. 0.82 minus 0.80 in the numerator gives me 0.02. Divide it by what you see in that denominator. Again, just be careful with your steps here with the calculator. And I am going to get, I've got 0.273, so to 2 decimal places I have 0.27 is what we're looking for. 0.27 would not be in either of the tails that I have sketched there in either rejection region. So we do not reject. And then to summarize that, we're going to look back at our claim. Our claim here was the null hypothesis. So because we do not reject, we're going to say there is not enough evidence to reject the researcher's claim. One other thing I do want to note on here, which I probably should have done this at the very beginning, but that's okay. It's not going to hurt anything to do it now. You do want to double check that this sample can be represented with a normal distribution. And the little kind of test we did for that was that NP and NQ were both greater than or equal to 5. So let's test that real quick just to double check that we're good. So my N was 30, my P was 0.8. N times Q, which was 0.2, 30 times 0.8 gives me 24, 30 times 0.2 gives me 6. Both of those are greater than or equal to 5, so it checks. If you did not have a value greater than or equal to 5, you would not be able to run your hypothesis test. So always a good thing to check, especially at the beginning maybe, so you don't do all that extra work, but it worked out for us this time, so we are good to go. All right, so again, you guys have some extra practice problems in Polaris. There's 6 extra hypothesis testing questions. I think there's at least 2 of each, 2 z-tests, 2 t-tests, and 2 proportion tests that are listed there for you. So you guys can take the rest of the period to look over those, practice those. Try some tonight. Remember, you guys also have a Math Excel that is due tonight. Your 6374, all your proportion stuff is due tonight, so you guys can take class time and work on that today as well. Finally, you have a bonus worksheet that I gave you last week that is due tomorrow at the beginning of the period. It's going to be worth 3 bonus tickets on part 2 of your test. So that's another option for today if you want to work on that bonus assignment and a little extra practice for you in class. All right, email me if you have any questions. Otherwise, I will see you guys tomorrow. Have a great day.